Okay, so today you're going to be learning about central angles, some arc theorems, and inscribed quadrilaterals. So fill out this additional blue sheet that you have. You can staple it to your packet either now or at the end. I just forgot to put these in there the first time. So first of all, the sum of central angles. We kind of already talked about this, but we know that the sum of the central angles is going to equal 360 degrees. So, all of these angles in here, pretend you had angles, all of these together will equal 360. So for example here, you have one that's 70, one that's 180, one that's x, and you figure out x's. So if we take 70 plus 180 plus x, you said equal 360, because all of these angles together always equal 360. So then we get 250 plus x equals 360. So x equals 110. So that would be your answer for this one. So again, go ahead and try this one. This one's a little different from the last two. See if you can figure it out. When you're ready, press play and get the answer. Okay, so we're going to take 150 plus x plus 90 plus 30 plus x equals 360. So now I'm going to combine my numbers here and get 270. And now I combine my x's, then I now have two x's. So having those two x's mean that these are going to be exactly the same measure. So I subtract my 270 from both sides, so I get 2x equals 90. Divide by 2, so my x in this one is 45. Okay, our next theorem is the chord arc theorem, which basically says that if you have two chords that are equal in length, these are equal, then these arcs are going to be equal too. Okay, so it works both ways. So if chords are congruent, then the arcs are. But you could also say if those arcs are congruent, then the chords are. Okay, excuse my sloppy handwriting. Right with my finger on the iPad. Kind of tricky. Okay, so for example here, we have 100 degrees for these. That means these arcs are equal. So therefore that means these two chords are equal. So all you have to do then is set them equal to each other, solve for x. So I'd subtract my 2x over, subtract my 1 over, so I get 18 equals 2x. Divide both sides by 2, so x equals 9. Now this one works the opposite way like I mentioned. So this time the chords are equal, so that means these arcs are going to be equal. So all you do again is set them equal to each other. So go ahead and solve here. Divide both sides by 4, so x is 5. Alright, two more here. Intercepted arc theorem says if you have two inscribed angles, okay, so my inscribed angle is here, so here's one angle, and my other inscribed arc angle is here. Okay, so I have two of them, and what you can see here is that they are meeting at the same arc over here. They have the same intercepted arc. We said an intercepted arc is an arc formed by inscribed angles. So if you have two inscribed angles and their arc is the same, so they meet at the same intercepted arc, then these angles are going to be equal. So that means these pieces are going to be equal to each other. So if same intercepted arc, then angles are congruent. So what you'll see here is you have two inscribed angles. Here's one, okay, and then you can see that they have the same arc, so that means you can set these equal to each other. So 3x plus 20 equals 6x minus 10. So subtract and add here, so x would equal 10. Okay, one more. Go ahead and try this one. Press pause, press play when you're ready. Okay, so here is one inscribed angle. Here's another inscribed angle. Here's the arc that they both meet at. So that means that these would be equal to each other. So 10x minus 10 equals 4x plus 38. subtract my 4x over, add my 10 over, so x equals 8. Alright, last theorem. Inscribed quadrilateral theorem. So we know a quadrilateral is just a four-sided figure. So we talked about this back in, I don't even know what chapter. We talked about inscribed means on the inside of a circle, where the circle would be then the circumscribed figure. So an inscribed quadrilateral would be if you had some sort of four-sided figure inside your circle. Okay, it doesn't need to be like a rectangle or parallelogram or a square or anything like that. It just is four sides. So it can be as goofy looking as it seems. And this theorem says, let's label these x, y, a, b. This one says that opposite angles in an inscribed quadrilateral are going to be supplementary. And if you remember what supplementary means, it means they add up to 180 degrees. So it means that x plus y will equal 180 degrees, and a plus b equals 180 degrees. So for example here, our ones that are opposite of each other equal 180. So if you add these together, they already equal 180. And then if you add these together, you could solve for x by setting them equal to 180. So subtract 100, so x equals 80. Okay, something like this. Like I said, these are across each other. They're already equal to 180. Now we can set these added together and equal to 180. So 5x plus 95 equals 180. Subtract, so we get 5x equals 85. Divide both sides by 5, and you get x equals 17, I believe. Yep, x equals 17. Alright, go ahead and try this last one. Pause it and press play when you're ready to see the answer. Okay, so as you can see here, these opposite angles are already equal to 180. So we need to add these up and set those equal to 180. So 7x plus 8x plus 30 equals 180. So 15x plus 30 equals 180. 15x equals 150. So x equals 10. Okay, that's your lesson for today. So there's 4 different theorems that you need to apply. They're all mixed up on the same worksheet. So you just have to pay attention to, when your sets up equal to each other, when you're adding up to 180, and that kind of stuff. Only reminder I have for you is that your Chapter 10 quiz is next week, Wednesday. Have this worksheet done for tomorrow, and the one from yesterday. We'll correct both of those on Friday.